The star Betelgeuse, a red supergiant located in the Orion constellation, has long captivated astronomers and sky watchers alike due to its enormous size and luminosity. Betelgeuse would extend all the way to Jupiter's orbit if it were placed where our Sun is, showcasing its vast scale. Despite being approximately 642 light-years from Earth, its sheer size makes it one of the most brilliant stars visible to the naked eye. In recent times, however, Betelgeuse has exhibited unusual activity, including unexpected dimming and brightening cycles. Many scientists believe this may indicate that the star is nearing the end of its life. The renowned physicist Brian Cox recently made a groundbreaking declaration that Betelgeuse is on the verge of a catastrophic explosion, anticipated to take place within the next 2 weeks. Betelgeuse's final stage of existence will be marked by this event, known as a supernova. However, it will also present an extraordinary opportunity for scientists to investigate one of the most powerful and stunning phenomena in the universe. As a massive star nearing its end, Betelgeuse is classified as a red supergiant, one of the largest and most massive types of stars in existence. It has been under observation for centuries, but its recent erratic changes in brightness have sparked speculation that it may soon go supernova. A massive explosion occurs when the core of a star like Betelgeuse collapses under the enormous pressure of its own gravity, sending an incredible amount of energy, radiation, and stellar material into space. Betelgeuse's imminent explosion is expected to be a Type II supernova, a specific kind of stellar detonation that occurs when the core of a massive star collapses. Neutrinos and radiation are released as a result of this core collapse, resulting in a shock wave that causes the star to disintegrate. The explosion will be so powerful that it may even be visible from Earth without the need for a telescope, possibly even outshining the Moon for several weeks or months in the night sky. The distance between Betelgeuse and our planet, approximately 642 light-years, means that although the explosion will be dramatic and visible, it will not pose any risk to life on Earth. This kind of event would typically be destructive if it occurred closer. However, this particular supernova promises to revolutionize our understanding of stellar death and cosmic phenomena. A supernova is one of the most energetic occurrences in the universe, releasing more energy in just a few seconds than our Sun will emit over its entire lifespan. The explosion of Betelgeuse will not only be a spectacular celestial display but also a significant scientific event. Using a variety of ground-based and space-based telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope, JWST, researchers are eager to monitor this rare event from the beginning. When Betelgeuse explodes, it will emit a wide spectrum of radiation, ranging from visible light to gamma rays. One of the most critical aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that seldom interact with matter. Neutrinos from a supernova can actually arrive on Earth before the light from the explosion itself due to their ability to pass through almost everything without interference. Observatories like Japan's Superkamiokande and the IceCube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, giving scientists an early start in observing the final moments of Betelgeuse. In addition, the explosion will provide crucial insights into how heavy elements are formed. When stars go supernova, they forge and release elements like iron, gold, silver, and uranium, materials essential for life as we know it. Researchers will be able to observe this element creation process in real time by studying Betelgeuse's supernova. Understanding how planets and the universe's chemistry interact is crucial. Although Betelgeuse's supernova is not expected to have harmful consequences for Earth, it will likely interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the arrival of cosmic rays and charged particles, could generate stronger auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays could potentially interfere with satellite communications and some technologies on Earth, any disruptions are expected to be minor and brief. One of the most exciting features of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with high-tech equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will not only captivate the scientific community but also engage stargazers and the general public, sparking renewed interest in astronomy and the cosmos. Astronomers have speculated for a long time about Betelgeuse's demise, but Brian Cox's recent statement makes the situation seem more urgent. In the coming weeks, observatories around the world are preparing to study every stage of the supernova, and the data collected will be priceless, potentially transforming our understanding of stellar evolution, core collapse supernovae, and the distribution of cosmic matter. Additionally, we will have a unique chance to improve our models of cosmic distances thanks to Betelgeuse's supernova. Being relatively close to Earth, it offers an unparalleled opportunity to observe how energy from such an explosion travels through space. By studying the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust that exist between stars, astronomers will gain a clearer picture of the universe's scale. This event will also provide a golden opportunity to investigate dark matter and how it may influence supernovae. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, doesn't emit or absorb light, making it difficult to detect. The behavior of light and matter around Betelgeuse following its explosion, however, may provide indirect clues about the role dark matter plays in shaping the cosmos. Betelgeuse's supernova will also take us closer to understanding the life cycle of stars, especially how massive stars contribute to the creation of the elements necessary for life. Supernovae are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even life. By studying Betelgeuse, scientists will obtain crucial data on how these elements are forged and distributed. The cultural significance of Betelgeuse's explosion is profound. For millennia, humans have looked to the stars for guidance, inspiration, and even meaning. The disappearance of one of the most prominent stars in the night sky will prompt philosophical reflections on the transient nature of the universe. Betelgeuse has been a constant fixture in the constellation Orion for as long as humanity has observed the stars, and its absence will serve as a powerful reminder of the impermanence of all things. In some cultures, such celestial events have been seen as omens or signs of cosmic change. As people from all walks of life witness a star's death, Betelgeuse's explosion may elicit a mix of awe, fear, and wonder. Moreover, Betelgeuse's supernova could revolutionize our understanding of gravitational waves, ripples in spacetime first predicted by Einstein and detected only in recent years. While gravitational waves are most famously associated with the collisions of black holes or neutron stars, a core-collapse supernova like Betelgeuse may also emit detectable gravitational signals. If instruments like LIGO, Laser Interferometer Gravitational Wave Observatory, or Virgo in Europe capture these waves, it would provide a completely new dimension of observation, allowing scientists to hear the star's death in addition to seeing it. Another potential outcome of the explosion is the formation of a neutron star or even a black hole, depending on the remaining mass after the explosion. A neutron star, composed almost entirely of densely packed neutrons, would be an object of extraordinary density. Just a teaspoon of its material would weigh billions of tons. On the other hand, if Betelgeuse's mass is great enough, it could collapse further into a black hole, vanishing from the visible universe and warping space and time in its vicinity. If a neutron star does form, astronomers may be able to study it as a pulsar, emitting regular radio waves or X-rays. This would allow long-term study of Betelgeuse's remnants and open doors to research on stellar remnants, magnetars, and exotic states of matter. If a black hole forms, though we wouldn't be able to observe it directly, the gravitational influence it exerts on nearby space could offer clues about its presence and formation dynamics. The coming weeks could also test our technological infrastructure and data-sharing capabilities. With observatories around the world poised to monitor the explosion, coordination will be key. Scientific institutions across continents are likely to collaborate in real time, pooling data from radio telescopes, optical arrays, and neutrino detectors to piece together a complete picture of the event. This global scientific cooperation could serve as a model for future large-scale cosmic events, where rapid response and open information sharing are essential. Importantly, Betelgeuse's supernova may serve as a wake-up call regarding stellar hazards elsewhere in the galaxy. While this particular star is safely distant, it raises awareness about the destructive potential of closer supernova candidates. Mapping the life cycles and locations of nearby massive stars could help identify future threats and lead to more refined monitoring of the galactic environment around Earth. The educational impact of this event cannot be overstated either. Schools, universities, and science outreach programs are already preparing to integrate Betelgeuse's supernova into their curriculums. It's a rare chance to engage a new generation with real-time astronomy, allowing students to not only learn about space but also witness history unfold across the cosmos. In philosophical and even spiritual circles, the death of Betelgeuse may also provoke existential questions. The idea that we are watching an event that actually occurred more than 6 centuries ago, its light just now reaching Earth, is a profound reminder of our place in time and space. What we observe is not the present state of Betelgeuse, but its past, a ghostly echo from the Middle Ages, when human civilizations were still forging the earliest foundations of science. Some may find comfort or awe in the notion that we are part of a universe where such colossal and beautiful forces are at work. Others may reflect on the contrast between the shortness of human life and the grandeur of cosmic events that unfold over millennia. Regardless of one's worldview, Betelgeuse's supernova will be a unifying moment, inviting all of humanity to look up and ponder the vast, mysterious universe we share. In the end, the death of Betelgeuse is not a finality, but a transformation. From its ashes, new stars and planets may eventually emerge, seeded by the heavy elements it cast into the galaxy. Its legacy will be written not only in the data and discoveries it yields, but in the imaginations it sparks, the scientists it inspires, and the collective memory of a world that paused to witness a star's farewell. Will mark the end of a giant star, it will also symbolize the ongoing cycle of creation and destruction that governs the cosmos. A reminder that new stars, planets, and even life could emerge from death as we wait for this huge event. The world will be watching the night sky, anticipating the moment when one of the universe's most powerful forces bursts into view. Betelgeuse's final scene will be nothing short of awe-inspiring for astronomers and scientists. As Betelgeuse approaches the final stage of its life, one of the more speculative yet intriguing possibilities surrounding its impending explosion is its potential to shed light on some of the universe's greatest mysteries, dark matter and dark energy. These elusive forces are believed to account for the vast majority of the universe's mass and energy. Yet, they remain poorly understood. Some scientists think that supernovae, like the one in Betelgeuse, may be the answer to some of these mysteries. Supernovae release an extraordinary amount of energy and radiation, and some researchers believe these powerful forces could interact with dark matter in ways we can observe and study. One fascinating hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If WIMPs do exist, their interaction with the energy generated by Betelgeuse's supernova could provide critical clues to their nature. Such a discovery would be groundbreaking, offering the first direct evidence of dark matter, an elusive phenomenon that has confounded scientists for decades. Similarly, Betelgeuse's explosion could offer insights into the nature of dark energy, the mysterious force driving the accelerated expansion of the universe. By studying how light and energy behave during the supernova, scientists may gather crucial information about how cosmic events like these influence the universe's expansion and how they might be connected to dark energy. The upcoming explosion of Betelgeuse offers a unique perspective on the life cycle of massive stars, which play a crucial role in the cosmic ecosystem. Due to the rarity of red supergiants like Betelgeuse, their study is crucial to comprehending stellar evolution. These stars form from clouds of gas and dust that collapse under gravity, eventually igniting nuclear fusion in their cores. As they exhaust their hydrogen fuel, they expand dramatically, shedding their outer layers through powerful solar winds. This mass loss contributes to the enrichment of the interstellar medium, paving the way for the formation of new stars. When Betelgeuse goes supernova, it will not only offer insights into its own life cycle but also serve as a cosmic laboratory for studying the conditions under which stars live and die. Researchers will closely monitor the aftermath of the explosion to determine whether a neutron star or black hole forms at its core. The nature of this remnant will provide valuable information about the physical processes that govern the final stages of stellar evolution. The dynamics of the explosion itself will also provide a wealth of information. The surrounding gas and dust will be heated and glowing brightly as a result of the shock wave caused by the supernova. This emitted light will offer astronomers clues about the elements synthesized during the explosion, such as iron, nickel, and other heavy elements. By analyzing the spectral signatures of these elements, scientists will be able to determine their abundance and distribution, deepening our understanding of how these elements propagate through space and contribute to the formation of future stars and planetary systems. Another area of interest is the potential for gravitational wave detection. As the core collapses and the supernova unfolds, it may generate ripples in spacetime that can be detected by observatories like LIGO and Virgo. Gravitational waves carry information about the dynamics of the event, potentially offering new insights into the physics of supernovae and black hole formation. Betelgeuse's explosion could also act as a catalyst for technological advancements in astronomy. The anticipated surge of observational data will likely push the boundaries of current astronomical instruments, potentially leading to breakthroughs in imaging technology, data processing, and real-time analysis. Beyond the supernova, these innovations may be beneficial to a wide range of astrophysical research. Public engagement will play a crucial role in Betelgeuse's supernova, fostering a sense of wonder and curiosity about the universe. Educational programs, outreach initiatives, and citizen science projects can use this event to inspire the next generation of astronomers and physicists. To emphasize the significance of comprehending the cosmos and our place within it, viewing parties, lectures, and discussions may be held at schools and universities. As we prepare for this monumental event, excitement is building throughout the scientific community and among amateur enthusiasts. The anticipation surrounding Betelgeuse's supernova encapsulates humanity's desire to explore the unknown, challenge our understanding of the universe, and unite us in our pursuit of knowledge. The death of a star becomes a profound reminder of the cycle of creation and destruction that defines the cosmos, urging us to reflect on our own existence and the mysteries that lie beyond. In the days, weeks, and months following Betelgeuse's supernova, telescopes around the world and in orbit will remain fixed on the expanding remnant. Multi-wavelength observations, from radio to gamma rays, will help construct a comprehensive timeline of the explosion's aftermath. Each wavelength will reveal a different layer of the event: the energetic shock front, the chemical composition of ejected material, and the interactions with nearby interstellar clouds. Space-based observatories like the James Webb Space Telescope and Hubble's successors will play a critical role in capturing unprecedented detail. Ground-based arrays will coordinate global observation campaigns, ensuring that no moment of this rare phenomenon is lost. This collaborative, international effort will mark one of the most unified scientific responses in modern astronomy. Additionally, the supernova's light echo, reflections of its flash bouncing off distant dust clouds, may offer a unique opportunity to replay the explosion. These echoes, arriving with delays due to their longer path, can be studied to reconstruct earlier stages of the event and validate models of stellar collapse and energy release. The cultural and philosophical impact of Betelgeuse's supernova should not be overlooked either. For millennia, humans have looked to the stars for meaning, guidance, and awe. The sudden appearance of a brilliant new light in the sky, visible even during the day, will stir imaginations across the globe. Artists, poets, and thinkers will no doubt draw inspiration from this celestial drama, reminding us that science and wonder often walk hand in hand. Religions and worldviews may interpret the event in ways that reflect their values or cosmologies. For some, it may symbolize renewal; for others, an omen or a celestial celebration. Regardless of interpretation, Betelgeuse's end will become a shared moment in human history, a convergence of ancient stargazing and cutting-edge science. Ultimately, Betelgeuse's explosion will not just illuminate the sky, it will illuminate our understanding of the universe and our place within it. In its death, the star will give birth to knowledge, insight, and inspiration, enriching both the cosmos and the consciousness of those who watch it unfold.